pioneering solutions, transformational technology, and inspirational leaders. I'm your host, Connor Sherman, and this is the Confident Defense Podcast. Welcome to the Confident Defense Podcast. I'm your host, Connor, where every week I sit down with VCs, CEOs, and security executives to have these really honest conversations about how to win in the infinite game of cybersecurity. And today is no exception. Today we have our guest, Mohit Tiwari. He's a professor at the University of Texas in Austin. He's the co-founder and CEO of Symmetry Systems, a company that's on a mission to amplify security engineers by building these products that help them discover, surface, and protect their most valuable assets, their data. Mohit, welcome to the show.
Thanks, Connor, for having me here. It's been a long time in the making. So.
It certainly has. It certainly has. And I have just been so excited to come here because not only do you have this incredible company that's solving this super important problem, there's a question I've been always wanted to ask you, which is what are the characteristics, or how would you describe the characteristics of yourself being the most humble CEO I have ever come across in my life? I looked at your page for the website and you're like on row 2. Like, you've built this company, which is about your product and your customers and like not about you. And it's just really amazing. So what got you into building Symmetry Systems?
Thanks. That's okay. So Symmetry Systems, actually, it's been also a long time in the making. We were at UT, one of my ex-students, now co-founder, CTO, and colleague, Kason Hunger. We were just looking at the research area that we all came from, just this esoteric field called information flow, right? And the promise of that field has been there for a long time, 30, 40 years, but around 2013, 14, 15, we just realized that the conditions were becoming perfect, right? Like, people were breaking up applications into microservices, right? Putting them into containers and orchestrating them and so on, and moving them into the cloud where the plumbing is really standard. So we just figured like, hey, this whole area exists that we've been studying for so long. The whole goal is put data security into the infrastructure. Like, instead of it's something that you're doing after the fact and trying to figure out, it's like part of your core infrastructure, right? Yeah. So that was the kind of genesis, and we just started from there.
So let's back it up. So you came as a university professor, you've been teaching there, you mentioned this topic of information flow. Can you extrapolate on what it is a bit more and why it was such a powerful concept, like that it would prompt you to like start this whole company and go down this whole universe?
Okay, yeah, that's really good, because the core idea behind information flow is that you can take a system, right, and you can come to it and say that you can literally say like, mark this data that I really care about. Let's say I really care about genomic data, right? Mark this as the color red, and now trace it as it flows throughout my infrastructure, as it goes from machine to machine, goes from application to application, from one cloud to another. Wherever it goes, it's this color is kind of spreading. And now you can, if you have this observability type of system built out, you can now ask questions that, hey, did any contractors touch genomic data in the clear? Or did genomic data ever get exposed to the public, to partners, to, you can just pick any question you want and you can start answering these. So
what's really I'm desperate to understand. Like, it's really interesting because I've seen this in the past where people start like, we can tag an asset, we can tag a pipeline, but it seems like there's almost this meta thing that follows the data object itself, and you're tagging the data function. Right. Is that a good framing of the problem? Like, is that a good way to think about the problem? Okay.
Yeah, that's really good. So there's essentially like 3 parts to it, and getting it tagged is the first part. That's why there is like a really nice link to data cataloging, data discovery, this type of like field that has already existed. It's been a tough field to make big traction on, but that exists, right? The second big piece is you need to be able to track the flow of this. That's where just tagging the asset by itself is not enough, because you'll have some service that will read it and store it over there. So now you need to trace this flow. And the last part is you need to put guardrails around it. Like, hey, this type of flow should not happen, right? So if you get these 3 things in order, that's basically the essence of, and now you can say genomic is read or Salesforce data that I'm hosting is red. You can just now start asking lots of flexible type of questions about it.
Got it. But it's but everything's based on this idea and this breakthrough that happened, and that we can now discover a piece of data, tag it, follow its life cycle through the whole thing, learn its normal patterns, and then we can make a decision. It's like, do we want our data to be doing that or not?
Exactly.
Got it.
Exactly.
What was the shift in 2013? I think you said 2013, if I got that, remember the date correct? What was the big shift there technically?
Yeah, so the technical shift really is that this field has been around for a long time, and it was just blocked by, it's really hard to trace this if you're trying to say like, hey, trace some sensitive data through a Word document, because it's just, really complicated piece of code, and you just lose the trace. Basically, it's really easy for your trace to be kind of broken, the tracking part to get. So if you're sitting on these really large SAP type enterprise apps, it's the same problem. You have this big monolithic app that just acts as the sinkhole for all these colors of data, and you just can't tell. Someone went into this app, it came out, you have no idea what data is coming out. Right. So around that time, like just the fact that people started breaking it into services with APIs amongst each other, right? That really helps with getting this trace going. And the second thing is just, that was not 13, 14, that was even before like the cloud type of plumbing, right? It's now possible to get our software plumbed into the cloud, and you don't have to walk to one dev team at a time to say like, hey, can I put this tracing around your app? And then, it's just ship it cloud wide, and now you're tracing it across the org. That is really powerful.
Got it. Okay. So I'm kind of getting my sense here. Okay. So we've always had this theory of what we could be doing. It started to become practical when Kubernetes and other microservices came up, but then became accessible to the masses once most organizations were on these cloud native microservices architectures using CI/CD pipelines and control change flows through their organization, and that you could hook into.
Right. And even just like plain old EC2, S3, old school cloud, even there, it's pretty useful, because, they're also like, there's some, because Kubernetes is like the extreme endpoint of having a microservice deployment. But even if you have EC2, S3 type of classic web services, even there, it's pretty helpful, because you still have services that are talking to other services and, pushing data through. Essentially, the backbone of communication is almost always, you push stuff into S3 or into a database or into Kafka, and then someone else picks it up. So you can sort of see how services are communicating if you just even watch the data stores alone.
Gotcha. Okay. Yeah, I think this is the reason I'm so excited about this breakthrough is because it starts to like answer this. There's these fundamental 3 questions as a security leader that it's so hard to answer. It's like, what data do we have? Where is it? And who has access to it? I mean, like, you think it'd be simple, right? You say, oh, service provider, like, what data are we collecting from you? What data are we giving to you? Like, and someone's got a notepad somewhere with this written down. And of course, obviously, the answer just doesn't exist.
Right. No, you'd think it. It's just hard problems. Each of those questions that you said under the hood are exceptionally challenging. But
yeah, I mean, let's dive into that.
Okay.
Yeah, let's get into it. So I want to know, like, because you guys do something that's really interesting and I really liked, is this idea that you can provide insights to those questions without taking my data away from me, without data leaving the premises, which until recently, like, that was a showstopper for so many organizations, right? They can't let the medical data leave to come back, or have someone scrutinizing it and then giving you the results. You have to kind of do it on site without the burden of doing it on site. So what's the mechanism for this?
Yeah, so that is another thing that the whole like cloud native tooling has really helped with, is that we can ship our software we can maintain it as a SaaS, right, where we are pushing updates continuously and so on, but we can push it into the customer's cloud, where the deployment of the service is in the customer's organization. That was just a very pragmatic decision, because we can't walk into a company and like, hey, we are a no-name startup. Can we protect your most valuable data? And by the way, yes, we'll take it out into our cloud. I mean, we would have been stuck in vendor assessments, for another decade. So that's why we started that. We just push our service into our customer's organization, And as a result, once it's there, it just computes it. Even we don't need to have access to it, right? We can keep super strong access control kind of protections. They can call us for help, right? And it's all in like this really controlled. So just creating our own service as an example of the kind of systems we want to see, like, where you have, SaaS services don't need to be multi-tenant in the same way all the time. Like there are some cases where they benefit a lot from performance, but in many cases you can just ship the service into the customer's organization.
Be the deployment model you wish to see in the world. Do that. Cool. I really like that. It's like this idea that, as a security leader, you can start to have this access without losing control, have this brokered federated way of letting people in when you need support. But in addition to like the regular, so I guess is what I call it, and I think other people have called it, is the idea of like SaaS in the customer's cloud. Mm-hmm. Is that the model?
Yeah, that's exactly right. And I mean, again, like we don't need to innovate a ton. Like a lot of the cloud native tooling where you have registries, container registries, code repositories, all pushing these things, right? I mean, JFrog has done super well in this space, right? Mm-hmm. You can set up the tooling such that on the maintainer side, it looks and feels as if, we're just maintaining a whole fleet of servers, but on the other end, the implementation end, they're all actually distributed across kind of to the edge, where the edge is the customer's environment.
So let's do this. Let's take a big step backwards. I want to get your perspective on the evolution of data security, right? I want to circle back in on those three questions, like how security leaders need to think about what data they have, where is it, who has access to it, and why it's tough to solve the problem and how we solve it. But can you just, for the sake of the audience here, just step back 10, 15 years, however far, and just kind of walk us through where did we start this journey? How did we get here? What have been some of the roadblocks along the way? And kind of like, why now time we can, and why we should be prioritizing this data security?
Right. That's actually a really interesting point, because coming out of academia, I would imagine that data security, there would be like a pretty solid consensus on what it's around, right? But it seemed that a lot of the definitions were around data loss prevention, right? DLP, which is a field that's been around for a while, and encryption. So encryption keys and so on. And then there's like this super niche area of, if I have to have a table, can I tokenize or mask a specific column? Like if I have a column of SSN, I just replace it with, random numbers. I think like this class of techniques were really the ones that were in this category, and they just don't meet the need of the kind of data stores and the same evolution that we talked about with microservices. On the data side, what it now means is you have a whole bunch of these storage services or data stores, right? They all host data, they're all accessible over APIs, and data is just flying in and out. Like when you have services that want to communicate with each other, they'll always put the like big blobs of data in these storage and then send a message to get it picked up. So if this is happening, the big change is that controls that we have built for, around like the database server. So, back in like early 2000s, Imperva started off with a database firewall, right? Like, and Oracle database has pretty good controls, and I'm assuming so has IBM has Guardium, right? That's pretty good. So these are all like really focused on the server. It's like a very application-centric model, even though they're talking about protecting data. They're talking about protecting the database application.
Right.
I think the mental switch is actually, that's not what we really want. I want to protect my genomic data objects. Like customer A just uploaded their genome file. I want to protect that. Now, what's happening to that? It lands up in S3, gets analyzed and so on. The results go into some, MongoDB or SQL database and then pushed as a stream to some other. This stuff is just flying around everywhere. So it's almost like you've popped up a layer from database security to data objects security. You want visibility into what's happening to my objects. So to your same questions, like where is my data, gets now translated into what's going on with my 10 billion data objects in my environment.
Yeah, I just want to pause there for a second, because we think it's like, you're bringing back like a bunch of PTSD around data access controls. Under SOX governance, it's like, do we have role-based access, and can we certify that this developer was supposed to access this table at this time? And it really was just like, it's sort of like who can RDP into the Microsoft SQL Server? Okay, like
Yes,
that
yes.
one's control number one, or who has these direct SQL connections.
Right.
To your point, we weren't trying to protect the infrastructure. Like it's just a server, right? It just runs compute. What we care about is what's inside the table. We care about what's on the objects. So it's kind of interesting that we've been able to kind of prioritize. I guess it's just like surfacing up the object that's important and kind of cutting away the dross.
That's
And
right.
now, because it's also not just sitting in a database, going through an ELT and then going back to it, it's being transformed and going through the whole environment. This makes it just that much more difficult to tackle.
And one other interesting aspect that we've been seeing is that there are so many different personas that are moving this around, right? So that if you put one type of controls for the data analysts, right, it doesn't seem to work for, because there are now SREs and developers logging in and doing stuff, right? And then there are security engineers. So just keeping a handle over, all these different personas that can come in and move data around is also a pretty interesting problem.
So what do you mean by personas in this context?
Oh, in this context, meaning that if you have a data lake, for example, right? Like I'm an organization, I just set up Redshift or Snowflake as our data lake. Now, the type of things I have to worry about, it's not just like, is the data lake, secured from the analysts who come in to do computations? Because the analysts are sort of coming through the front door, right? They'll come in and they'll be like, ask for access to the data, and they will get it. Every quarter, they will renew all the permissions, entitlements they have, and in steady state, everyone is accessing a lot of stuff, right? So there's that class of problems. But then if you turn around, you're like, who's maintaining this data lake? So now there's a whole like site reliability engineers or SREs or data lake admins who are maintaining this data lake. Then there are people like partners or developers who have upstream databases that feed into this data lake. They have to worry about. So it's like there's just a whole lot of cooks in this data lake kitchen that as a security team, you need eyes on kind of all of them.
And there's never been a problem with a third-party contractor logging into sensitive data and stealing it. That's never happened, right?
And sometimes even putting stuff in, but some of our customers are like, actually, we signed a BA or business associate agreement. You will not send stuff here, but you did, and now if something happens, I don't want to be responsible for sitting on PCI data or whatever.
See, BAAs, I have a love-hate relationship with that concept. I'm like, okay, protect yourself legally, but then everyone's like, cool, no need for real security anymore. It's like we just sign that risk to somebody else, And there's probably, if we follow the map of BAAs, there's probably some poor individual in the center of this whole web where all the liability actually lies. But reminded me of a great XKCD cartoon. But so, this is the idea. Okay, so we move from the infrastructure, we're moving to the data object, recognizing that it's just not front door access. There's this side door access, or there's the people who maintain the access and the SREs. There's this side door access. I imagine also services are directly interacting with it. Absolutely. They're running their transformations, moving it around to the next thing. So
those service roles are huge sources of just need for monitoring as well. Absolutely. I'm glad you mentioned that.
Yeah, let's talk about service roles for a second. So I found this really difficult to figure out what permissions things actually have in AWS. I mean, thankfully there's some tooling coming out that allows you to understand effective permissions. But I mean, this has been kind of haunting us since the days of, even in Active Directory land and things of that nature, just like groups on groups on groups on groups on groups. Like, what does this thing actually have capabilities to do? How do you guys get through that? How do you guys break that veil?
Yes, I'm glad. That's a really interesting point, because these permissions, I feel like sometimes we expect too much from just this permissioning as a tool, right? Because in a way, when we're making role-based permissions or attribute-based permissions, what we're doing is we're trying to compress the permissioning spec, right? In theory, I could just go down and for every person, Alice has access to literally these, buckets and objects and databases or whatever, right? We could list out person by person. It just gets onerous. So we are like, okay, let's just make a role that combines a bunch of these permissions. And so it's a natural sort of like a compression point where lots of users go to a role, go to lots of resources. So if we are doing it and we have a large infrastructure, by definition, these roles are going to be these junction nodes that, that many people can come to and many places that can be gone to from there. right? So it is just going to be a choke point no matter what we do. I mean, if we want compression, right, the better compression we ask for, right, the more we get. So to me, it's almost like we should do this. We should do best effort in least privileging the accesses. But if you think about Tableau, for example, in a data lake, it needs access to all the data stores because then it can show for each analyst, whatever data store they have access to, right? And there are a lot of applications like this: Tableau, ThoughtSpot, Informatica. If you look at a web-facing workload, it's facing the internet, obviously, so you can't not have it do that. And it has access to all the customer data in databases that, like all the assets from SQL, NoSQL, S3. I mean, it needs it. So if it gets OWASP, it's going to be, so to me, service roles are just like a necessary, problem, right? We want compression.
Yeah. So we want compression because it gives us operational simplicity.
Yeah.
But with that comes this hidden risk.
Yes.
That it sounds like as we're compressing these functions, we end up, it almost reminds me of, what is that? Is it which law of thermodynamics is that? Where if you take something and you compress it, like heat has to come out. It's energy, we compress it and risk comes out.
Yes.
It's like the third law of Connor's thermodynamics, totally botched on a podcast. Yeah.
Connor's law of risk. What's it called? Like, conservation of risk. If you reduce it here,
we don't want to conserve the risk. We want to get rid of the risk. Yeah.
Yes.
That's actually a very real thing. It's like we just keep like shifting the risk and like moving it from place to place.
Yes. Well, but like to me, one example that did it really well is all this move towards SSO, right? Like instead of having every single app having username and password, we have like SSO, but then we put lots of guardrails around it. So it's almost like a refactoring job. But then the second half is to put a lot of really great guardrails around that thing that we refactored. So if we make the same analogy to the roles, it's like now, okay, it's okay to compress it, but now turn around and let's put a lot of detection response and other guardrails around the roles themselves. Right? How are the roles being used? How are the service roles being used?
Yeah, so that's very true, and I like that. I think one of the things that when you and I were talking offline about kind of what's going on under the hood, one of the things I think you were showing me, and I want you to correct me if I go wrong here, as I got to understand DataGuard a bit better, was this idea that like we see that Connor has these roles. So we see the identity Connor. He's got these roles. He also has these individually associated thing. Being able to kind of compress that, figure out, normalize that, so you understand the effective permissions. And then I think the next piece is really important. Is like, what is actually being used? I mean, as a security leader, that's huge for me because now I can be like, when I go to say we need to pare back your permissions, you're not just being that guy. You'd be like, look, you've never used this CRUD function. Can we just remove it if you're a liability? You're not adding any value with this.
Right. So you brought up two really, really good points. So I definitely missed this point in the permission story, is that you're pointing out that like AWS is the perfect example, right? There are so many types of permissions that in the end, how do they all collapse together? And how does Connor get to this particular object? Is it through just this role, or is there another role? Is there some attribute is there some other group? There's just so many different paths to it that just being able to unroll this kind of graph of like, roles, like you access one role, then from there you get access to another set of roles, then just figuring out this transitive permissions graph to get to like, here's the fixed point. Here's one, the dust settles, and here are all the paths for, offboarding is such a huge challenge. Like someone leaves, you're like, okay, how do I offboard them? You take them off of SSO, but then there are so many different types of permissions that, they might have created before as part of normal job, and they're still sitting on. So being able to walk through all this and unhook the ones that you need to take out is a pretty major challenge. And the third thing is usage. That's a whole different evidence-based security teams thing that you pointed out, which is pretty important. But I just want to pause here because I think you're going to say something.
No, that's a great phrase. I'm going to steal that. Evidence-based security teams. I thought our job was like hype and FUD. No? Am I doing it wrong?
Yeah, right. No, because like what you just said was great. Like if you go to a person and just say that, look, here's the usage, here's the evidence, if we do this, the risk comes down by this much. I mean, every data team we have worked with, or DevOps, prod teams we have worked with, they really like it. Like, it places security teams in this position of like, you're like a product person in a normal startup, right? You're using lots of measurements and judgment calls about your area of expertise and coming to the rest of the teams with like, hey, here's what we think you should do and why. And if you're put in this position now, security teams look pretty good, because it's not like, oh, principle of least privilege says take this off. It's like, hey, here's the risk, here's the usage, here's what we think you need to get, to reduce business risk. Sorry.
Totally agreed. And I just had a very long conversation on LinkedIn with two folks, Henry Stanley and James Chiappetta, and they'll be coming out as a podcast here. But basically that whole idea of moving security into a product mindset and thinking differently about security. We're not a project. We're not as like, we're a service to the organization. We think like a product. But so I think this is a pivotal shift, because when you think about what makes successful product leaders, it is this data-driven way of viewing the world. What do our customers actually want? What are they actually using? Where are the actual pain points? Where do we see the app crashing, right? They have this data set. And I think security teams, we sometimes do get lost in the attempt to enforce a principle without arriving with the data. And I would go as far as to say, like, the data is just not going to, a data story won't discredit a principle. If they did, it wouldn't be a principle, right? It wouldn't discredit it. But what it would do is inform us how we achieve that principle, how we implement that principle.
Right.
And that's what I'm hearing. Like, what I see in Data Guard is just this idea, like, cool, okay, like, let's not go fix permissions. Let's go fix the right permissions in the right way at the highest risk, because this is the data that matters the most, and kind of be able to tell that story.
Right. Exactly. I think you're very right. So, I mean, that's why we kind of backed away from, when we started off, we're like, oh, container-based access control, all this stuff. We just backed into, let's just give a tool that helps inform security teams' judgment and gets them the evidence to drive the org towards change. And the driving part could be, if you are a very Splunk-heavy, detection response-heavy place, you operationalize it that way. If you're an IAM-heavy shop, you operationalize it that way. It's like security teams have to decide, like, okay, which lever to pull that, over time gets the org to move, towards a better posture. So
yeah, every team has a different cultural hot button, and you can just, as a leader, you're like, okay, today it's this one, and tomorrow it's that one, right? So you know which ones to use effectively to help, serve the customers, which in our case is the company and the customers whose data are entrusted to us. So as we walk through this evolution of data, I was really intrigued to see that, okay, great, we've moved past infrastructure, we're getting into data. We kind of couldn't talk about data without talking about identity. It feels like there's a convergence of things happening here, and there's no Gartner quadrant for this, so I'm very lost. How do I do this, Mohit? Like, how do I solve this problem here?
Well, I know. Yeah, it's a good point. You're very right. Like, I think that this is sort of the evolution that's, as you mentioned, that, if you can state at the highest level the goals for security, sometimes, but in many cases, come down to this type of identity should not do or should always do this type of actions on this data, right? Like, contractors should not touch genomic data in the clear. Developers should not touch customer data in the clear unless they go through this one, controlled box. Information should not flow from our federal VPC into our US or EU VPC. Like, you're sort of creating this goals around data, and now challenge almost is like you have to now go and translate it into, okay, what are the cloud IAM and what's the AppSec and what's the, like, different detection response type guardrails. That's where the translation breaks. So if we can make a direct link between the goals we have at this, high level goals into, here's the data type, here's the identity type, and we can make this connection, that should be like a natural evolution. Now, I feel like Gartner is getting there, because if you look at their IAM research and their data security research, they both are talking about, oh, identity used to be the perimeter, but now, hey, identity and data should be the perimeter. I forget, I think David Marty or someone wrote a really good article around getting IAM to have a data perspective to it. Right? These are like the two most durable things, right? Machines and networks sort of come and go. Data security guys are doing this data risk assessment, which gets to this visibility into where's my data at risk, right? And I think there's also a third set of teams, I think from privacy, who are working on this to try to figure out specifically for consumer data, but the same questions can be generalized to genomic data or some other data.
Yeah, I'm right there with you. I think, as we've seen over the past, 15 years or so, there's just been this world has gotten, we've gotten smaller, and the smaller we get, it's almost the more effective we can become, right? We've gone from like a tank to a samurai sword. I don't know, if I had a better analogy, right? We've gone from like the network to the compute to the identity to the data, and they're still all important, but it seems that we have more tooling now to think about these problems differently, and with that brings more agility to how we manage our risk, right?
Right. Yeah, because if you can state it for identity and data now, if it's Lambda touching it, if it's Snowflake, if it's wherever it goes, the kind of constraints can follow the data, right? So yeah, I agree.
Yeah, so that makes sense, and it almost allows you to, as a security leader, start to pivot. What's the most important object? Maybe what's important is the data you have. Okay, maybe what's important is the transformation of the data. Sometimes it's just availability, right? You are there, your service is to be up. Okay, so now is really the infrastructure that's more important than the data object flowing through it, right? So it allows us to be more thoughtful in.
Absolutely. If you're running a nuclear power plant, you
Yes.
don't care about the data. The software needs to be up.
Yeah.
Availability.
There you go. That's a good analogy. What I'm thinking is like a Maltego chart, right? And you get to take the node that's most important and say, this is what it is now centered, and everything kind of orients itself around it based on the organization. The organization, are you a genomic company or a nuclear power plant?
Right. Even for nuclear power plants, one interesting way things go down is this, kind of data, as we've been talking about confidentiality more, right? You can pitch it as an integrity problem or an availability, and you can say like, hey, this is the set of parameters that our nuclear plant relies on. No one tamper with these, right? So the first one was a read problem. This one is almost like a write problem. Like I don't want, all updates to these important things should go via trusted means, and random other stuff should not overwrite it. Sometimes that integrity is also can be postulated as an information flow or data flow problem, or more topically ransomware, right? Like ransomware is a write problem as opposed to data breach being a read problem.
That is very well said. Yes, that's very well said. And of course, if we had good controls around our data, we would know who has read-write access to it. We'd have the whole story, and therefore we would be in a better position. Maybe the desktops are getting encrypted, but like what's most important to us isn't. Like we still home because we know we've got good controls over that. So I am interested. You mentioned this idea that we're kind of breaking this down, and we're getting. You mentioned earlier this concept of like we can have these policies, but they tend to die on implementation. My language, right? It starts to break down on that. It seems like there's an opportunity for us to change this landscape here, and really move into this policy as code type of way. Do you agree with that assessment? Do you think this is something we should lean into more? What are your opinions around that?
No, I think that's a very perceptive point. This is related to the point we were earlier talking about. It's like the more commodity or kind of openly specced out the plumbing becomes, right? Hey, here's how DynamoDB's controls work, right? Whether it's like proactive controls like role-based things there or detection response. And then you can say like, oh, here's how S3 works. Here's how every single data store, let's just using AWS as an example, work. You can now state like, hey, this data, no matter where it travels, right, should always have these constraints that, people, identities of type ABC should be the only one who touch this, right? And now you can have this sort of synthesis/policy engine in between that is taking. And if you have a proactive mode, you're like a greenfield app, you could synthesize those policies, right? That views get created in a database where all the PII is stripped out and you only get to see this aggregate views, right? And now your policy is being proactively implemented. Or you can be like, hey, this was the policy. Now I can put detection response guardrails type. When this breaks, you find out. Because a lot of times when you have legacy deployment, you just have to actually figure out, is this policy even true right now? Right. So So depending on your org, you can use policy as code in either one of these two styles, right?
I
But
really like that.
simplifying this policy is pretty important.
I really like that idea of like being able to do this data analysis on the data, like who has it, where is it, and who has access to it. Not as only this enforcement, but also as just risk management. So as a security leader, being able to plug it in and say, okay, here's what my world actually looks like versus what I think it looks like on paper when I've gone through my manual interview process.
Yes. Yeah, I agree.
So what are some of the primary use cases that you're seeing people? So the early adopters who are changing the space, because this is a rather new space, right? I think most of the market's still on protect the infrastructure, kind of waking up to the identity, but that whole story of like data object protection is brand new.
Right.
So what are some of the early adopters? What are the use cases they're solving with this?
So one of the things that we didn't expect going in, but we found through trial, is that just environments seem to be sitting on a lot of dormant data, right? That just got created, and analysts were using it, or developers brought it in to build features or whatever, right? And then people just moved on, and the DBAs themselves, they just don't know, right? Because they don't know what the business use cases are of everything. So there's just a lot of kind of default table stakes risk that can be cleared up if you just remove dormant data, or as Gartner has called it, dark data. Absolutely.
It's way cooler. It's got like a Thor thing going on. It's got like, Ride of the Valkyrie. Yeah, definitely the dark data. Yeah.
Right. So that's been a pretty major value proposition, where if as a security leader or engineer, you come up and you say like, hey, here's all this stuff, like who wants to say anything unless and we're going to like sunset this data or move it off to cold storage. Chances are almost very high that it is not being used. So most people are like, no response comes, and you've just cleaned out a whole bunch of risk, without ruffling any feathers or rattling any cages. So I would say that.
So it goes back to the evidence-based security, right? You could show up saying, here's my Maltego chart, here's my whichever way you visualize it. No one's touched this in 3 years, and here's the services that would, blah, blah, blah. Yeah.
Right. So that's been a table stakes solid win. But once you start going from there, there's like permissions risk, where you're saying like, hey, here's this kind of filter your data landscape by like where's the most sensitive data and what kind of exposure does it have. So it just surfaces this point where like, oh my gosh, this super valuable data that doesn't need to be this widely accessible. So our companies that we have worked with, they've been able to just get. Sometimes security teams and cloud ops teams are two separate teams, and the permissioning is in the hand of cloud ops, whereas security is in the hand of obviously security. So they've been able to again provide this evidence and get this collaboration going, where like, hey, let's least privilege our environment in a way that exactly that tightens the permissions, but it doesn't disrupt business. So actually, Netflix has pioneered some of this stuff through their RepoKit tooling, where if anything has not been used, to access to a service or something, you can pull it back. We noticed that if you put a resource or a data focused lens on it, you can drive it down a lot more than just pure service alone.
Got it. Okay, so again, moving beyond the identity story. So in that Netflix example, like the identity is getting sunset, if I heard you correctly. Right. You're saying let's take it up a notch and let's get rid of the data.
Right.
Because that's truly where the liability lies, right? Like credentials, compromised credentials is an avenue for which the risk can be realized, right? It's an avenue via exploitation. So closing the door is cool, but to actually get rid of the thing, the data itself, if someone wants to walk through that door, there's nothing there. So
Right. That I agree. And there's a really nice complementary controls. Like to me, this seems like identity related security and now data related security are probably, hopefully in 5 years or something, they could be like the first two rocks in the jar, right? Before we go chase every developer to fix every CVE in every app, because apps will have CVEs, and that's just what they do.
Come on, you're breaking my heart. Why are you going to tell me I still have to chase down vulnerabilities in 10 years from now?
Just trying to figure out like which levers are longer in some.
That is exactly right. It's that sense of like, what is our Archimedes lever in this story here, and I absolutely love that quote you're referring to. With I think it's Galileo or is it Archimedes who said it, which was like, give me a lever long. No, Isaac Newton. Give me a lever long enough and a fulcrum in place, and I can move the world. Right. And I just Love that analogy here, especially what you're talking about here with technology like this.
Right.
So I wanted to. I think you've helped me move, and the audience move this idea. Okay, we move from infrastructure, we move to identity. Now we're the data object layer. Once we have that narrative, we can play to the strengths of our teams inside our company. Right, either protective because we got really solid engineering. It's detective because we got a solid incident response team.
Right.
What's the other thematrical? What are some of the other problems and use cases that are coming out once organizations kind of are equipped with this tooling?
Oh, I see. So I guess we were going through the Dormant stuff. There's the permissioning. I think another one is that, because permissioning will go out of date no matter what we do, right? And like we said, a lot of service roles will accumulate. So you have to kind of assume a bunch of risk no matter what you do. I think that some of the big use cases have been, if you're setting up a data lake, for example, right?
Yeah.
And it's just with Snowflake being awesome and Redshift and BigQuery also doing really great, that whole space has just exploded in a good way. So I think this is a great opportunity to put kind of programmatic controls around data lakes, right? Like policy as code type thing, where you can say toxic stuff should not come in here, or if it does, it's contained within these zones. And within those zones, like the type of identities can do what type of transformations on it. They can't see stuff in the clear. So I feel like you can build a really principled organization, because there's always this tension, right? Like as a company, you're pulling in so much consumer data, and as a security team, you want to be responsible for it, right? But you still want to enable your analysts to make business queries and business-related analytics and so on. So I feel like this trade-off between the analytics guys just sitting and trying to get access to really valuable data sets on one side, versus on the other end, everyone has access to everything, and it's just a nightmare where you just signed a BAA and you ship the whole Postgres database dump over to the partner, right? I think like we can strike the nice balance where enough utility can be had, and like lots of solid protection, just like we have for identity here for data we can put around these data lakes. So to me, that's a really exciting use case that's coming up. The other one has to do with devs, but we can double click separately into that.
Okay, let's double now. Let's go into devs. How do we support and enable them?
Right. So to me, there's just this. So in the research side, when we look at applications and apps, like it's like, okay, static analysis, dynamic, that stuff is just, you're expecting so much from tooling. Right? If you have some Node.js application, you should just assume that it's broken. Right? There's no amount of, like little incantations that's going to get rid of. Like,
Mohit, tell me what you really think about Node.js.
Or the same thing when we say supply chain tooling. I mean, it's all AppSec. It's all in. As soon as you install an app, there's like a million things that come in, right? So, to me, a longer lever is to kind of the service mesh is awesome. Like you can put controls around the data and make it part of the service mesh, and now you just free up your developers to use whatever library code, whatever they want, and assume that it's basically broken. But even if it is, only a very small fraction of data, like that particular user's data, is the only thing that's in this box. So when we think of containers, it's not app containers, we're thinking of data containers. Right.
Got it. Okay. So we assume, I guess it's an extension of that principle. Assume you've been compromised, right? Assume that something's going to break.
Right.
How can you minimize the damage?
TCB, right. Your trusted code base, how can you put it into the infra where like we can put pro-grade defenses around it, versus, my entire app is my trusted code base. Any indirect object reference, any OWASP vulnerability, any buffer overflow will just, now this app is issuing requests directly to the database kind of thing.
Yeah, and I mean, this is also a problem we couldn't really solve until we had this level of visibility, because how many architectures are out there where it's like this container needs access to this table today, but it may need access to the other ones. So yeah, we're just gonna give it the whole access to the Redshift cluster or the RDS cluster because we don't know what the future is going to hold.
Exactly.
Now we can say like, no, actually, you just need these objects on this database at this time. We can have those layer controls. That makes sense. Okay. But again, I love that idea. Just introducing more resilience into to it. And I know there's, it's like least privilege. We talk about these things, but like my favorite anecdote around that is it was Benjamin Franklin who designed that whole compartmentalization as a technique to stop ships getting sunk when they were shipping. So
Right.
he was on a boat between the U.S. and France as a diplomat, and he realized if we get a hole in one place in this boat, we're all going down. So
Right.
he sketched out like boats and putting in compartments. And I mean, that is just a transformative framework because you say, cool, let's assume we're going to get a hole in the ship. Now let's just put a door on that and contain the water over there before the whole thing goes down.
Right. Right. I really like that. I think like to your point about principle of least privilege, if you take a very app focused lens into the matter, you'd be like you said, this app needs access to RDS, S3, MongoDB. Of course, that is least privileged. But if you look at it from a data lens, you're like, wow, this one app is accessing every single customer's data, right? How can I kind of put much smaller compartments, like you said, where smaller subset of users' data is in the compartment?
That's a really good perspective shift on this. Yeah. Just as leaders, just looking at it through a different lens and reorienting our framework on that. So, Mohit, I could talk to you all day about this. So I think I'm going to bring us to a close and wrap up. It was an incredibly cool conversation. But with that, I'm going to leave you with 2 rapid fire questions. What career advice would you give to yourself 10 years ago?
Well, I would say prioritizing sort of like people who you think are doing really awesome work and are really awesome people to work with, like as a way of choosing next steps. I think when I made those moves, they were like they panned out really good. And then sort of figure out what problems can we collaborate on, and then which technology or whatever to use to solve the problem. So in this order, at least was the times when things worked out well for me.
Okay, so select the people, then select the quality of the problem, then pick the technology.
Yeah.
Okay, cool. That's actually a really good insight. Okay, my favorite question, and I'll leave you with this, everyone. If there was one innovation you'd want every security leader to embrace going forward, what would that innovation be?
Actually, one pretty big lever to me seems to be this kind of SaaS in your cloud type of deployments. If you're talking, because vendor risk assessments are a ton of work, and then if you sign the BA and hand over all the data, then you just like take the risk as well. It's just a ton of work for very little leverage. So it just seems to me that the technology seems to be aligning towards where this is very feasible, and we are trying to do it. I know other companies are also trying to build products like this. I feel like the timing is right, and companies could be asking their customers like, hey, this is great. You can pull the data out into a SaaS, but you can give me the same sort of SaaS-like updates and so on. But can you deploy this in my cloud? I think that's a good question to ask.
Put the control back in the customer's hands.
Right.
Then we can kick them out anytime we need to.
That's
great. Well, Mohit, thank you so much for today. And everyone who's listening, I just want to thank you. Like, these are the caliber of conversations we have every single week on the podcast. So we bring in CEOs like this. We bring in security executives to help us win at the infinite game of cybersecurity. Until next week, I will see you there. And Mohit, thank you again for your time.
I really appreciate it. Thanks.